Hey everybody, the purpose of this video is to discuss balancing redox reactions in both acidic and basic conditions. And there are several methods to accomplish balancing redox reactions in acidic and basic conditions. The method I'm going to show you today is the half reaction method. We're going to start out by balancing our reaction in acidic conditions, and in order to do that, here are the 7 steps that we will follow. First, we'll identify the substances that are oxidized and reduced. We'll separate the overall reaction into 2 half reactions, the oxidation and reduction half reactions, respectively. We'll balance all the atoms in each half reaction in the following order. First, all non-hydrogen and oxygen atoms. Then we'll balance oxygens by adding water as appropriate. And finally, we'll balance hydrogen by adding H+ as appropriate. Step 4, we'll balance the charges in the reaction by adding electrons as appropriate to each half reaction. Remember that electrons have a -1 charge. Step 5, we have to make sure that the electrons gained and lost, so the electrons in each half reaction are equal, and this may require us to multiply one or both half reactions by a small number. Step 6, we're going to add those modified half reactions together. And step 7, we're just going to check to make sure all atoms and the charges on both sides balance. So let's look at an example here. The reaction we'll look at today is iron 2+ reacting with the permanganate ion to produce iron 3+ and manganese 2+. The first step in our process of balancing this in acidic solution is to identify what is oxidized and what is reduced, or identify oxidation and reduction. To do this, the first step is to assign an oxidation number to each atom in the reaction. And you can see that I have done this here for each atom. That's not the focus of this discussion, so you'll just have to trust me that those oxidation numbers are correct, but they are assigned to each atom. We now want to compare oxidation numbers for the same atoms from reactants to products. So for example, you'll note that Fe goes from 2+ in the reactants to 3+ in the products, and this is an increase in oxidation number, which means the substance is oxidized. Similarly, if you look at the manganese atom, it goes from 7+ in the reactants to 2+ in the products, and therefore it is reduced. It got more negative, or it is the oxidizing agent. So we have successfully identified the species that have undergone oxidation and reduction, and we are ready to move now to step 2. So in step 2, we're going to separate the overall reaction into our 2 half reactions. And by that I mean we're going to write the oxidation half reaction and the reduction half reaction as a separate reaction. So we've already identified the species undergoing oxidation as iron. So our first reaction, our oxidation half reaction, has iron 2+ as a reactant and iron 3+ as a product. The second half reaction will be the reduction half reaction, and in this case it is the permanganate ion, MnO4 1-, going to Mn2+, the manganese 2+ ion. Now that we have successfully separated our overall equation into 2 half reactions, one for oxidation and one for reduction, we can balance each of these independently and then add them back together to get the overall reaction. Step 3 asks us to balance the atoms in each half reaction in the following order. And we'll start today with the oxidation half reaction. It doesn't matter whether you start with the oxidation or reduction half reaction here. I just happen to pick oxidation. The first step here is to balance all atoms other than hydrogen or oxygen. And you will notice here, that means for this reaction, we are balancing the underlined iron atoms. And there is one iron atom on the left and one iron atom on the right. So we're good. You'll also notice that there are no hydrogen or oxygen atoms present in this particular reaction, so we can ignore step 3-2 and 3-3 here for balancing oxygen and hydrogen, because this half reaction, as it turns out, at the moment, in terms of atoms anyway, is already balanced. The reduction half reaction is a different story. If we go to try and balance this one, again, step 3.1 here is balance all atoms other than oxygen or hydrogen. So let's identify those. That is the manganese atoms on both the left and the right side. And you'll notice, again, there's one manganese, Mn, atom on the left and one on the right. So 3.1, that step is already met. But we have not met steps 3.2 and 3.3 in this case because there are oxygen atoms at least present in this reaction. So to balance the oxygen atoms, we have to add water. So you notice there are 4 oxygen atoms on the left. So we expect, when we look at our balanced equation in the moment, to see at least 4 waters on the right. So we would add 4 waters on the right to balance the oxygens. When we add 4 waters on the right, that will add 8 hydrogens to the right-hand side of the equation. So we'll have to add 8H plus to the left-hand side of the equation. And so if we look at that balanced equation, we see on the left-hand side, MnO4, 1 minus, plus 8H plus reacts to form 1 Mn2 plus and 4 H2O. So we see our 4 water here on the right-hand side as we expected, and we see our 8H plus on the left-hand side as expected. It's worth pointing out at this moment that it does not matter what order you write your reactants and products in here, as long as they're all present in their appropriate states with their appropriate charges and their appropriate numbers. Let's continue on then to step 4, which is we are going to balance the charges now by adding electrons. Remember, electrons have negative charges. We're going to do this for each half reaction. So in the top half reaction, the first thing we're going to do is calculate the total charge on both the reactants and the product side. On the reactant side, the total charge is 2 plus. On the product side, the total charge is 3 plus. So we will need to add 1 electron to the right-hand side because 3 plus plus 1 minus gives us 2 plus. So now the charge on both sides of the oxidation half reaction after the addition of that 1 electron is 2 plus, and the charges are balanced. We're going to repeat for the reduction half reaction. This time, on the left-hand side, we have a total charge of plus 7, minus 1 from the permanganate ion, plus 8 from the 8 hydrogen ions, gives us plus 7 on the left. And on the right, total charge of plus 2, that is from the 2 plus ion, from manganese 2 plus ion. To make these charges balance, we're going to have to add 5 electrons to the left side. 5 electrons to the left side, because 7 plus plus 5 minus gives us 2 plus. And now the charge on the left and the charge on the right in the reduction half reaction balance. Both are 2 plus. The next step is to make sure that the electrons in the half reactions equal each other. Okay? So you'll notice in the oxidation half reaction right now, there's only 1 electron that is lost, but in the reduction half reaction, there are 5 electrons that are gained. Those don't equal each other. We can't gain electrons that don't previously exist, that have not previously been lost. So we must multiply the top reaction. We must multiply the top reaction by 5. Multiply it by 5 so that we get 5 electrons lost in the oxidation process. When you do that, you end up for the oxidation half reaction being 5 Fe2 plus yields 5 Fe3 plus plus 5 electrons. Note, the reduction half reaction does not change. We are now ready for step 6, where we add the 2 reactions together. I find it very useful when doing this to line up the arrows so that I can clearly see in each reaction one is a reactant and one is a product. If something is a reactant in one reaction and a product in the other reaction, it will cancel out. In this case, you will notice that the electrons are the only species that are the same in both the reactants and the products. So those 5 electrons cancel each other out. And then we add these 2 reactions together. And when we do, we get 5 Fe2 plus plus 1 MnO4 minus plus 8H plus gives us 5 Fe3 plus plus Mn2 plus plus 4 H2O. This is our balanced redox reaction in acidic conditions. The last step is just to verify that all atoms and charges on both sides are balanced. And as you can see from this little table, which I find a handy way to keep track of this, they are. We have equal numbers of all atoms in reactants and products, and the charge on both sides is plus 17. Plus 17. So this is the balanced reaction, redox reaction in acidic conditions. How do we convert that reaction to being balanced in basic conditions? Well, it turns out that we're going to follow the first 6 steps exactly as we have done previously, and then we're going to insert, shown here in blue, a new step 7, where we will neutralize the H plus by adding OH minus to both sides of the reaction. And then, again, we will check to make sure things are balanced. So let's stick with the same example we've been working with. That is our reaction of Fe2 plus with the permanganate ion to produce Fe3 plus and manganese 2 plus. That was our original problem. We want to balance this now instead of in acidic conditions, in basic conditions. We already know what to do in step 6. So at the end of step 6, just to remind us, we had 5 Fe2 plus, 1 MnO4 minus, 8 H plus, 5 Fe3 plus, 1 Mn2 plus, and 4 H2O. So we had this balanced equation right here. Now we can proceed with the new step for basic conditions, which is step 7, and that is to add OH minus to the reaction to neutralize the H plus. You will notice in our balanced equation to this point, there are 8 H plus on the left-hand side. This means that we are going to add 8 OH minus to both sides to neutralize the 8 H plus on the left and to keep the equation balanced. So we'll add 8 H plus to both sides. And when we do that, we end up with a reaction that is 5 Fe2 plus MnO4 minus plus 8 H2O yields 5 Fe3 plus Mn2 plus 4 H2O plus 8 OH minus. If you inspect this reaction carefully, you will notice that there are 4 waters on the right and 8 waters on the left. In other words, it is true that 4 waters cancel out. And when we simplify this reaction, we end up with 5 Fe2 plus MnO4 minus plus 4 H2O gives us 5 Fe3 plus Mn2 plus 8 OH minus in basic conditions. The last step is just to confirm, and so again we make our table here and notice that the number of atoms of each element is the same in the reactants and products, and that the charge is the same in both reactants and products, in this case plus 9. That means that this is the correct balanced equation for this reaction in basic solution. I hope that this video has helped illustrate the half reaction method for balancing reactions, redox reactions in solution.